Now we've done all the pre-prep work and we've successfully eliminated into danger areas and everyone seems to be working. So now we need to calibrate it. We need to work out where it is and what it's doing. So the first thing to do is get yourself a tape measure, pen, pad, and if you should have seen the laser guided center finder. You've got your little laser pointer. So first thing to do, get this pad and draw a tiny little dot in the middle. Sticky, it needs to be a stick-it note or something like that. Get your tape measure and actually measure the height from the table to the bottom of the nozzle. Mine is 223.5, so it looks like, so 223 will round up. If we go back several pages ago, when we done the end stops, in the software, it said it's been set for 239. Ours is only 223. So that's a difference, was it 239, 23, 16 millimeter. I know how I've added an extra 10 millimeter on the top, as you know. So if I was to hit Z0, you'll try pushing through the table 16 millimeters. So that's why we know we've measured, we've got a rough idea, and we now know there's a danger that we may hit the bed. So that's what we keep in mind. So that's all part of the calibration, and that's the settings we have to change using Notepad++. On page 106, HO1, it's telling you Z tower, the print, Z axis and all that. But it needs bed center and the actual limitations. So we need the home coordinate, 0, 0, and Z max, which we measured to be 223.5. Yours may be even a lot less. If you've got the 10 mil, yours might only be 213. And center of the bed. Getting the head to move down in the Z position. If you use the graphic interface, you've got plus or minus 100, 10, 1 and 0.1, and on Z 10, 1, 0.1. So that's how much it will move. That's the steps. So you click on 10, it will move 10. You click on 100, it'll move 100. But, and this is the gotcha, if you're entering the G code into the little bar here, and you say, go to Z10, which is your G1, so if you put G1, X0, Y0, Z10, you think, oh yeah, 10 above the table, we're 16 out. It will then go this way to be 10 above 0, not 10 step, 10 above 0. So that's the difference. That moves it in steps of 10. G code moves it, GR1 moves it to that position. So think of G code is on a ruler and you want it to move it to 0 millimeters or 10 millimeters or 15 millimeters. So think of it as having the tape measure there and you want the head to go to 0 or 10 millimeters or 15 millimeters or 20 millimeters. That is the difference. Appreciate it now before you've damaged anything. So we'll just do a minus in the Z 0.1, 1 millimeter, 10 millimeter. Home all. We'll just test it. We'll just do a 10 millimeter in the Z direction going down. So that's the bottom of the scale. Plus on Z will be 10, 1.1. So on there. Working fine. Page 110, HO5, it shows you the measurements that you need to find. You need to define the lengths of these sort of triangles so as it knows where it is in 3D space, and it uses mathematics to calculate that. So you need that center to center distance of the push rods. That's what we set it to at the very beginning. You've measured it, you've recorded it, you know what it is. Just to remind you again, put it there to there, that is 300. If you have a little flat tab like that and you're not that sure whether it's pushing in or pushing out to get the measurement, move up to the next, say 100 mil and use that to center it with. Remember to take off 100 on your reading. So that's 230. So you've got your notepad, you write down that height. One there is called the delta diagonal rod. We say it's, call that number 1, delta diagonal rod, 230. It says it's set to 213, so there's a variation. Delta rod smooth offset is this one. That at the moment is 158. Use your one datum for all your measurements, 135. So that's 135. We know that the center, 157. We know from there to there is 157. From there to there is 135. Simple mathematics, 22 millimeter. So number 3, delta effect offset, 22 millimeter. On here it's saying it is 20. Carriage is 15. when they design the carriage, and if you design your own, you should just use standard units, 15mm, 20mm, when you design something, so calculations later can be a lot easier. So we have done those measurements. We haven't found the accurate centre yet, but this is just the starting point. So then we need to refine it. So we know that of the measurements that are inside the software, according to the PDF file, are completely different to us. So we would only have heaps of trouble if we tried to print at the moment. We will adjust them later when we get closer to the bed. And the reason why you have the little dot in there is that we put the laser in the center and we just put the little piece of paper with the sticky to line up the dot. Then you pull it off and it just sits there, and then you can accurately measure it. So we'll do that later. I'm just going through the steps, what it says in the manual.